There you go. I can see you better. So you might want to start sizing your screens up and getting ready for class.
I'm gonna use the bathroom.
All right, come on back. We got 8 minutes before we start. He could have just left the room going. He left the room to go to the bathroom. All right. So that's it. That's it. Clock is started recording. Yeah, I did that already. All right, now let's set up my attendance. Oh, there you go. I was like, dang, why he leave? He just went to the bathroom and came back. All right. Okay, so we're about to begin in 1 minute. Let me get the attendance list ready. Welcome back to class, Jacqueline. Been missing for a little bit. Welcome back. Let's see here. Okay, so we're gonna start our norms in a minute. I'm trying to give students 1 more minute. We start class at 10. So when that clock expires, we can jump into our norms. I do know students will pile in. So when this clock expires, we're gonna start our norms and everything. I'm just trying to give students a moment to get in the classroom. While you're waiting, you want to try to make sure you set up your screens. That's why I'm doing this. I know the staff like immediately going to norms. I'm like, yeah, but they need time to get settled. So like just now, there's another student coming in here. I try to follow what the staff tells me, but I do understand how the human interaction works. Okay, so Aaliyah, you're here. See, this is what I was talking about. After about 5 weeks of doing this, y'all need time to get in the room. Lisa Brown, yeah, welcome to class. Aaliyah's on it.
Hey, Mr. Kelly.
Hey, Lisa, welcome back. I didn't see you yesterday. Is everything all right?
No, I had sent a message saying my Wi-Fi was messing up.
Yeah. I did get that. I did get that. I forgot about that. Were you able to get access to the videos yesterday or no?
A little bit, but I had asked the students, can they help me with the work?
If who? Okay. All right. Well, everybody, get ready. It seems like Aaliyah's already ready. Let me get these norms going. So you want to have two screens, right? Because you got a report to type up. It's the same procedure every day. So I'm just resizing my screen. You should be doing the same, right? Just grab the edges from the sides or the tops of the browser and have two windows open, right? Yeah, so 2 more minutes. You can go through our norms. Make sure you're logged into Edsby. Make sure you are in the Google account you want to use for your Friday quiz and go to Docs. Start a new document and get ready to take notes. So I got to do attendance real quick. We're going to get started. So we got Mr. Allen is absent. Lisa Brown is present. Thank you, Aaliyah. I see that. Jacqueline Camacho is present. Mario Carvajal absent. Kylie Childs absent. Christopher Clark absent. Courtney Dixon is present now. Leo Garcia is absent. Romel Lee absent. Rashad Lockhart absent. Angelique Llewellyn, she was here yesterday, absent. Aaliyah Mims is present. Angel is, ooh, wait, Courtney, it's gonna be tough on you, man. Make sure you can get to your Google Docs or take snapshots of the notes because you still got to turn it in today. Angel is present. Thickpen absent. Wallace, I got to follow up with him. He came to class and then stopped. He's absent. Who else? And Miss Worthy absent. So goes the roll call. How much time I got left? Did I do that on time? I'm about to submit this to the office. All right, looking good. Okay. I got Lisa too, right? Yeah. Jacqueline. Okay. So let's share this to the office so staff know. All right. So entire duration of class, you got to try to keep your camera on. I understand if you're on the phone, it's limited. But when I am checking on you, got to turn your camera on and speak. Okay, so just keep that in mind. Not picking on you, not putting you on the spot. But this is CPS policy to make sure the student that's in class is the student that is supposed to be in class, not your friend or somebody trying to sit in there because you don't feel like being in class. You have to be on the camera, right? So let's keep going. The norms. Let me stop this clock before it starts ringing and y'all talking. I knew it. It said like 10 seconds. And blow this up a little bit. I'm going to start from the beginning, which is our 5 basic norms. So I'm going to go through the list and call on you guys. So first in my list, of course, is the lovely Aaliyah Mims. That's because she has A for a name. It goes in alphabetical order, in case you're wondering. So it doesn't go by last name. So it's Aaliyah, then Courtney. So you'll figure it out as I call you. Number 1, Miss Mims, can you read that?
No one has the right to hurt another person.
Thank you. Courtney, can you read number 2?
Education in the classroom are sacred.
Thank you. So who's next? Jacqueline, number 3. Yeah, turn your mic on, dear. Miss Camacho, are you there? Oh, my mic don't work. It was working the other day. What happened? Oh, Mr. Irvin's here. You gotta check on her. If you don't, your mic is not working. It's hard to get points, Jacqueline, because you got to speak. Let's move on to Lisa. Can you read number 3?
We would never behave in a way that would discredit ourselves, our school, or our family.
All right. We only got a few people in here, so I'm going to read number 4. An Excel Academy of Southwest student is always a lady or a gentleman. Let's keep going. Number 5, back to Aaliyah. Oh, Courtney
We
left.
take pride in the Cell Academy of Southwest.
Thank you, Aaliyah. All right, so let's move to our academic norms. Jacqueline can't read, but Lisa, can you read number 1?
Respect the opinions of others.
Okay, Courtney came back right on time. Courtney, can you read the number 2? Can you see it, Courtney?
No, this phone's tweaking. It say respect the culture of the classroom.
Thank you, sir. Jacqueline can't read. Let me read that one. We are attentive and participate. That's why we call it. Jacqueline, check your SB inbox. Thank you, Irvin, for getting on that. So what was I saying? Number 3, I think it was we are attentive and participate. That's why I'm calling you guys to see if I can catch you off guard and if you really are, worthy of the points for in-class participation. Number 4, Aaliyah, can you read that?
We have high expectations for ourselves, our peers, and our teachers.
We always should. Thank you, Aaliyah. And the last one, Miss Brown, can you read that one?
We are here to focus on preparing ourselves for post-secondary endeavors.
Thank you, Lisa. So quick question, easy 10 points if you can tell me, well, easy 15 points if you can tell me all 3, because it's 5 times 3, that's 5 points for each part. But what are the 3 post-secondary endeavors that we would use? Courtney's trying to get some points. What are the
It's
3?
military, college, and trade school.
So at the same time, at the same darn time, there was Lisa and Aaliyah that got it. Lisa put it in the chat. Aaliyah said it. All right. Welcome back, Angel. I thought you was gonna take a bathroom break, man. You came back late. You had to call your people, man. What happened? All right. So let's keep going. Mr. Tyler, do you mind if I pull Courtney for a couple minutes? Sure. I don't mind at all. What was I about to say? Our assignment for today, right? So you should be logged into SB and you should have your screen size the way mine's are, right? I hope everybody took time to do that because we're going to be starting our document off. So we name it Do Now. I'm hurrying up with this because I got a few students in the chat and a few students like Aaliyah who are saying things, so they know what to do. And all these video recordings and transcripts will allow me to see if you get the points or not. So if I'm checking it out, don't think I didn't get the points. I review these videos as I put them on YouTube and make sure they're on ESB. So you'll notice the significant scores change. Now, a lot of scores in ESB haven't changed too much because we're coming towards the end. I'm trying to give you guys time to go back in time and finish this workup because I think we end November 5th, if I'm not mistaken, and the quarter's done. The grade book closes. And I don't want you to be like, well, what can I do? You know, that last week of school, what can I do? And I'm gonna look at you like, I don't know. What should you have done? It's gonna be a problem. So please try to go back and finish up anything you think you can finish by watching the videos, one, and the videos show you step by step what to do. And two, also making sure you turn the work in. Okay, so let's jump into this, right? I said you're gonna write Do Now for the title, and today is the 20th, and October is almost gone. Year is flying by fast, even with COVID. So next thing is what? Your header. Let me zoom in a little bit. And that'll be, your header is your name, right? Can I spell my name? Okay. And also, what is it? The date again, 20th of October, 2020. And period. That would be second. And in parentheses, you put physics with algebra. Class focuses on a lot of algebra, even though it's physics. So just get good with your algebra, and this is an easy class, everybody. All right, title. Let me go to the chat. I think a few students, let me see who get points for it. Courtney did it. Earlier, it was Aaliyah. Let's see, what's the current? Oh, okay, so she got it wrong, then she got it right. Right. Okay, Aaliyah, pretty good. So Aaliyah got me 2 classes. she pulled one from another. Aaliyah, you talking about robotics there. All right, so the 3 forces is the one you want to use, like Courtney did, right? Courtney said the same. Yeah. So that's the title, right? And they got points for that. So let's type it in. You can copy it, but you got to edit. Today's title is the 3 forces. We're still dealing with Newton's laws. In the bracket is the term of the day. So I was about to ask, what is the word? I mean, the term of the day. Leah and Courtney got it. You see, yeah, Leah, Courtney got those points before I could ask. Just easy points they're getting. Now, you can't rely on just the points to get you through the class. You got to turn work in. If you haven't turned any work in, please check that because you have a whole bunch of points and you only took care of maybe 2 or 3 assignments per week. Because remember, every day it's like anywhere from 25 to 30 points that pretty much build up. And that one assignment that you might have missed gets repaired. That doesn't take care of an assignment that you miss or many assignments you miss. So go back and fix this. You guys got about maybe 2 more weeks of class left before we start a new quarter. All right, so let's look at this. Who's that? Courtney? Yeah, go
Is
ahead.
that link that Mr. Irvin put in the chat still right there?
Yeah, it's still at 10:19 a.m. Yeah, I see it.
Can you repost it for me, please?
Okay. And thank you, Aaliyah, for posting the questions. That's what goes into the document next. But let me do the exit slip. You got points for that, Aaliyah. Thank you.
Yeah, I came
Courtney,
back.
I just put it in the chat. Do you see it?
All right, there you go. All right, cool.
Yeah,
Thanks,
you got
Tyler.
it. Okay. No problem. So exit slip today. What? It's worth 25 points. How many people actually take advantage of those 25 points? No? All right. So what do you need to get the 25 points? 1, the classroom term. And Courtney and Leah helped us out with that. And what is that? Well, that they already got the points because it's in the brackets. All they did is figure out what the title was. And that is net force, right? Not net in force. What is our word of the day today? Now, I need somebody to help me out with this because I was stuck in a meeting with Tillery and I didn't see what the word was. I think I got it. What'd you say, Lisa?
Harry put it in chat.
Oh, thank you, Lisa. Eccentric. That was the word of the day? Okay. So eccentric. Right? So you need the definitions of both those words. I'm seeing students put just what I put there and thought they got the points. Put the definitions. What is net force? Definition. What is eccentric? Definition. Automatic 25 points to your day, right? It goes to assignments you didn't do too well on. All right. So let's go through this. The questions. I think Aaliyah helped us out with those. So let me grab those from the chat and put that into our Google Doc. You literally should have everything I have. So when I ask for a share out, you won't be like, oh, I still didn't do. Be like, well, what were you doing? Were you like talking to a family member? Were you outside? What were you doing? Twirling your fingers? You should have been typing with me. So this much is what you should have done, right? You should have your document named, right? So you can find it in Google Drive. You should have the header. So when I pull it up, I can give you points for that. This is about making sure you have the right format or neatness. The title, the exit slip, and then lastly, you need both questions. This much you should have. So I'm going to slow down you 2 minutes to catch up, and then we're going to go into today's assignment. But we have a simulation, so we can't spend too much time. I just want to give you 2 minutes. After you get this done, get over to the physics classroom, okay? So the physics classroom is here, and that's the link I put in there. If you need this link again, I've been sharing it every day. If you need this link again, I can post it in the chat, or you can go to yesterday's recording, and it's right here, all right? You click on that, and you'll get to this slideshow. Inside the slideshow, you can click on me. You come to your class, and I got to change this, but we just talked about what these are. But there are simulations in here, and we're going to use a simulation today where we build a circuit. And it's going to be this simulation here. But first, get all that typed in, because I want to do the simulation, get that out the way, and then do the steps to the problem. Or maybe I should do the steps to the problem first and see if we have time for simulation, because you got to still turn this work in. So I'm going to do it in reverse. I'm going to do the steps to the problem, and then we're going to do the simulation. But definitely click on the simulation link so you can get this simulation going. You can click on this one, and you should get this right here, which allow you to create a circuit, not a circuit. We're doing forces, right? I'm thinking about robotics. That's the wrong one, I'm telling you. So in physics, where is y'all forces? Here's the apple. Is that the right one? Man, I love being smart. Yep. So we're going to do the simulation. You're going to click on the apple, and the apple will take you to that simulation you just saw. So make sure you get that loaded so we can get, and you're going to click on net forces, which is hint the classroom term of the day, and we'll take a snapshot of some things happening in here. So have that running in a different tab. All right. So how much time do you guys got? Because you should have got a lot of that document done. Oh, I'm out of time, so we got to move on. All right. So move this out the way, blow this back up. So here's where we're at so far, right? Everybody should have this much, right? I showed you what you should have. So now let's go through some initial steps to understand this. All right, I hope you're taking notes. Center your notes, because these are notes to do the problem. So what do we start with? Well, we got to understand that we looked at Newton's second law, F equals ma, right? Yesterday. Now we're looking at how you would use that for multiple forces, right? So in multiple forces, net means the total amount of forces. And maybe I should have done that simulation anyway, so you can visualize it. I don't want to just be talking to you guys. So I'm gonna switch screens to the. I'm gonna go ahead, because it's hard for them to understand if they don't know what they're looking at. So let's do this. Let's explain what net force is. And, this kind of helps you get your exit slip, because the term of the day is net force, right? But here's where it comes from. So the question I'm going to have in the chat, let's see here, Angel, can you read 1S that Aaliyah put in the chat? He just walked off the screen. Angel, you there? Okay. Can you read? Go ahead, Aaliyah, because it's like he busy.
You say you wanted me to read what?
So you see what you put in the chat, 1S, Mo, Larry.
Mo, Larry, and Curly push on a 765 kilogram boat. Floats next to a dock. They each, how you say that word?
They each, where are you at? They each exert.
They each exert an 80.7 newtons,
Newton.
sorry, force parallel to the dock. A, what is the boat acceleration if they all push in the same direction? B, what's the boat's acceleration if Larry and Curly push in the opposite direction from Mo?
All right, stop there. Cool. That's all I need you to do. That's 10 points. That is our problem, everybody, that we're going to work on. Now, she read that, but there's some initial values you need to understand. So Newton's second law is used again, but it's called Newton's second law. This is a caveat. So Newton's, there you can see my screen, second law. The first law is inertia, and this is for multiple forces, okay? First part of your notes, what is that comprised of? We're gonna go right into simulation and explain how to get this problem done. So what does that mean? Right? Some students are like, what you mean? I'm gonna tell you. So the sum of forces, right? Each F equals ma is equivalent to what? Well, the mass times acceleration. Google help me out with that one. It's like, we know what you're talking about, Mike. So sum of forces is plural, equal to the mass times acceleration. How do you do that mathematically? What does that look like mathematically? Let's go to insert, special characters, and we're going to choose sigma, but make sure you choose math first. Okay. And I'm letting that load. And in your math selections or categories, you're going to type sigma. Sigma is this E that looks very cryptic. And click on that, and you have this symbol. Okay. So let me blow this up some so you guys can see it a little better. Because that font of 10. Let's do 12. Right? Times New Roman. So it looks pretty professional looking.
How do you
All right.
spell sigma?
How do you spell sigma? It's Sigma. Put it in the chat for you, Lisa.
How did you do that, Mr. Tyler?
Thank you.
What, the sigma?
Yeah.
So go to insert, special characters.
Insert.
You get this menu, go to math. And then you type sigma, Sigma. And you're looking for either this one or this one. Means sigma, the summation of all things. We're getting into the understanding of what a net force is. Did that help?
Yeah.
Okay. So the next one is force. So that means all forces. Remember, sum of all forces. That means sigma F is equivalent to what? Well, that's the mass, is M, multiplied by A for acceleration. Okay. So that's your first mathematical equation. How do you measure these things? That's one thing I skipped, right? So what are these things measured in? One, the sum of forces is measured in newtons. Each force is a newton. It's equivalent to the mass, which is always measured in kilograms. So you can figure out how to do the problem, right? And then lastly, what is acceleration measured in? If you don't remember, it is meters per second and squared. So I'm going to put a 2 here, and I'm going to raise that to the power of 2. Format text and raise it by superscript. And turn the superscript off. And parentheses. All right, so now we have all the elements we need to begin this problem. All right, and this one requires a little algebra. But I want to pause for a second and give you guys this in the notes so you can catch up. There you go. And I'll make the transcripts to the chat available in case you get lost in the sauce or something. But I put it in there best I can. You got to edit the way I have it. Now, real quickly, everyone go to the simulation so we can give you a visual as to what's happening. To access this simulation, I want you to go to your physics classroom in the slides. I'm going to fix this in a moment. But click on the apple. Okay. See this apple here in the cabinet or the cubby holes? You click on that apple and it'll bring you to this simulation. So you guys about, I want to say a minute, no, 2 minutes to catch up because we're going to go through the simulation, take a snapshot, and then do the problem. Everybody get to this simulation real quick. And the one you're clicking on is net forces.
Who's this? Oh, I got a tomorrow. Tomorrow, for sure, tomorrow. Because I ain't want to miss today. There's too many days missing out of school. So
You miss
tomorrow.
what tomorrow, Leah? What are you talking about?
Oh, I'm still.
Like, what is she
I'm
talking about?
sorry.
It's
I was
okay.
on the phone. I was supposed to go get my state ID tomorrow. I was really
Oh,
supposed to go
Lord.
today.
Oh, okay. All right, so we're down to 6 seconds. We're going to go through right now, I guess. Yeah. So we're going to go through the simulation. And in this simulation, if you can see my screen, I think you can, yeah, you will do these things, right? So this is net force. And here's what I mean by net forces. We're going back to this understanding of what that letter that you guys saw, the sigma means, right? It means summation or sum of forces. So there's multiple forces that I'm going to put onto this simulation that you guys should have running. You got to do a snapshot. So first things first, let's put some forces on there. So the first force is going to make a very small force. This little guy, this middle guy here, right? I want to say he's middle, but he's the second one. And put him onto this rung. So you see he has a force that's going left. I'm going to take this bigger guy, and you notice his right force, because he's bigger and he has more weight, is going to be to the right. And then you hit go. And you see a tug of war, right? Of course, this guy's going to win because he's bigger, stronger, and he has force going that way. All right, so let's return. Turn on some of these actual metrics. And don't forget to turn on the sound so you can see what's happening visually and as well as hear what's happening. So you see everything. You have the sum of forces that we talked about a minute ago. That's our net force. You have this force over here. But we want to make an extreme amount of forces on both sides to see equilibrium. So I'm going to get all the guys up there. You notice when you hit go, well, let me ask you, what do you think is going to happen when I hit go this time? Who knows? Oh, Lisa put the link in there. Okay, thanks. You could also get it from the classroom, but thanks, Lisa. So what's going to happen when I hit go here? Anybody know?
Can I just guess?
Sure.
Is it gonna like stay in the middle or something? I don't know.
Very, very good, Lisa. If you notice, the sum of forces is 0. So it's a term called in physics balanced and unbalanced forces. Unbalanced forces is taking one of these guys and look what happens. We got a little more force on this side. But if I take a guy from here, it's just going to be 0, and they're just going to end up winning, right? So you have some inertia there too. All right, so what do you need for your snapshot? Because we got to get this problem done. Look at the time. You're going to click down here and just make sure you have a difference of forces in your picture. So one of these sides should be unbalanced. I mean, you should have a sum of forces going either this way towards the left or this way towards the right. Make sure all of your dials and all your measurements are on by clicking on these meters and take a snapshot as soon as you hit go. So the second after you hit go to FET, screenshot, all right, you get pause, and come back to your document and put that simulation picture in there. If you don't remember how to do it, let me do it with you. So you have these notes, and the next thing is a simulation picture. So I'm going to insert, image. I already downloaded my screenshot, upload, and we're going to put this into our document. All right, so that is how it's supposed to look. I'm just going to resize it a little bit. Okay, so that's our simulation piece. To move it around easily, what I would do is, everybody, is make sure you click on wrap text here, and then you can move it around as necessary. It also helps move down the question so you know what the question is and it doesn't interfere, because you got steps to this problem. All right, so work on that. But now I'm about to move into the notes for today's assignment and how to solve this problem. All right, so everybody should be back at the Google page and have this much done.
Mr.
Yes.
How do you? Okay, I screenshot it, but how do you put it in the Google Docs?
So you click on, go back to your Google Doc after you screenshot and download it, right? You click on insert, image,
Image. Okay.
upload from computer, and then you got to find your download.
Okay.
All right, so let me get these steps out of the way because we're running out of time, everybody. Class is moving fast, and I got about 11:10, so I got a little time. I think I can get all of it done. But you guys got to take good notes. If I'm moving too fast, just take a screenshot if you can and go back and type it up. Or you can watch the video because it'll be available later on today. All right, so let's go through it. I know some students, they write down notes as they go through. So here is what you got to deal with. Your known values. So known. And I'm also trying to move fast enough to talk about a little bit of the homework or asynchronous problem. So known values, what do we have? Well, we got to understand that the force of Mo, right? So Fm, but it's going to be a subscript M. So I'm going to put Fm, but M is going to be subscript. And you got to type it the way I'm doing it. Let me go to 200 so you can see what I'm doing. So Fm, that's the force of Mo in the problem. Format, let's subscript that. It should look like that. Turn it off. Is equal to FL. Subscript that. That's the force of Larry. All right. Format, turn it off. Is also equal to, because all their forces are pushing in the same direction initially in part A. FC for force of Curly. Curly. Turn it off. And all of those are equal to what? Let's go back to our problem. They gave us a number and the amount of newtons for forces. So Mo, Larry, Curly push on a 765 kilogram boat, which floats next to the dock. They each exert an 80.7, right? 80.7 Newton force. So let's go here. That's 80.7 newtons. That's our first known value. Next is what? Well, our mass. And mass is measured as M. That's equal to what? They said how heavy was the boat? That's 765 kilograms. Right here in the problem, everybody. Okay, no problem. So it's 765 kilograms. And we have, this is all part A, by the way. So we'll put part A here. Part B of the problem says what? Go back up. I'm just doing the known values, and unknown we'll do last, so you can see what to do. So part B is saying, hey, what's the boat's acceleration if they push, just Larry and Curly push in the opposite direction of Mo. So Mo is still pushing in the same direction, kind of like these forces, right? But the only person that changed up is Larry and Curly. So we got an entirely new situation. So we got to list some more things. So the first one is what? Well, Mo is still pushing at what? So FM for Mo is going to equal, come down to part B, the same thing. He's pushing with 80.7 newtons. Next is the other two. We have the force of Larry and Curly doing the opposite. Now, Larry Curry's pushing opposite of that number, so that's going to be negative. It's like we did with the simulation. It's going the opposite direction. So they're going like to the left-hand side, where just Mo is going to the right. So it's the opposite of 80.7 newtons. Okay, so unknown values. What are we asking for, or what is the question asking for in both of these parts? So if we go up here, you'll see that both questions are asking for the acceleration, right? That's the 8. Say what? Are you talking to me, or is the problem always going to be about the Three Stooges? No, Lisa, that was real funny. No, Lisa, it's not going to be about. That was the only problem we did about the Three Stooges. What are you talking about, girl?
No, that's just in case I come across this problem again, so I can know how to do it.
No, it's only one problem like this. Good that you know about the Three Stooges. You got an old soul. I used to watch that when I was a kid. But that's where it comes from too. So let's keep going. So the first part A, you're asking for acceleration. So part A is about acceleration, right? In the X range. So that's going to be, what do we say? AX. I'm going to say lowercase a, big X, but it's going to be subscript because that's acceleration in the X range. Now, X is across I want to say the horizontal of what you're looking at. So that's why it's AX. Okay, that's how it's supposed to look. It's equal to some number we're going to calculate in meters per second. And it's going to be squared, right? So we put 2 there and raise it. So that's meters per second squared. Okay, awesome. So far, so good. Now we need part B. And part B is going to be the same thing. So let's do this in sections. But it's going to be for what happened in that new situation. Okay. And don't forget, this is also going to be measured in the X range. So across the X for acceleration. So I'm going to put that there. Okay. We got 2 AXs we got to find. Acceleration for A and the acceleration for part B. And that's just doing some algebra in both. Which is why we don't have a lot of time. Because if you don't understand algebra, it's going to be a headache for you. Okay, so let's get this over with. The first strategy for part A is, you got to find acceleration. So we gotta use that equation above to get acceleration by itself. So strategy is to solve for x, right? I'll make sure that's known. You're solving for acceleration in x range. And this is what you're solving for. I just want you to know. Using algebra. Okay. So what is that? How do we do that? What do you mean, right? As students say. Let's go back up here. This equation I gave you is the mathematical version that you're going to use algebra on it. Get acceleration by itself, or ax. Because believe it or not, this a right here is ax. Right? So I'm going to change it up a little bit so you understand that. Because it could be ay or ax. That's why I didn't really put it. So this is the equation we're using. And I'm telling you guys that this is the same as writing ax, right? Or ay. So put this again. These are similar equations, right? Okay, so now that we have all that pretty much completed, turn it off because I don't want that to be a headache as I'm typing. There we go. 10:51. I'm doing good. Almost through with this. All right, so now we can do the algebra on it. And we're going to use this one here because we're in the x range. We're across the horizontal. We're not up and down, right? Vertical. We're horizontal in this question. So I'm gonna underline that because we're using this one and highlight it too, so you know which one we're using out of the selection. Okay, so now we got to get this solved. So I'm gonna take this version and do that, and I'm gonna solve for ax in algebra. All right. So let me turn that off. And as we go through, we got to understand that what you do to one side, you got to do to the other in algebra, right? So how do we get ax by itself? Well, it's real simple. The only thing attached to the ax is mass. So it's being multiplied by the mass, and that therefore means you want to isolate the mass. So since it's multiplied, the opposite of multiplication is division. So let's put some parentheses around all this. And we're going to divide by something. And that something is our mass. All right, so let me just highlight the changes real quick with colors. So this is the changes from the above equation to the next. But remember, what you do to one side, you have to do to the other. So that means I got to take this division of mass and do it to the other side of the equal sign. Parentheses around this, and this, and there we have it, right? So the changes also these parentheses because we want to make sure we isolated that. All right. So now some things are going to cancel out, right? I'm just doing basic algebra. At this point, algebra should be your friend because it's all I've been doing since the start of the quarter. Can I go back to the top a little bit? I can, Leah, but remember, we're cutting into time for the homework problem. So give me a second. I'm going to finish this up, and then I'm going to go back to the top. So what cancels everybody is all of this right here. And I'm going to give you guys about 2 minutes to catch up because we still got to put numbers in and we didn't get to part B. If we run out of time, you're going to have to try part B on your own. Let me cut this out. There we go. So the new equation, I'm going to scroll up for Leah for about 2 minutes. It's going to be this, right? All of this is gone. And all of this is gone. You end up with a new equation. I'm going to rewrite it so it looks better. go. So that's our new equation. Right? It did what I didn't want it to do. There you go. That's how I want it to look. And now we just put the forces in there, right? So what does that look like? But let me stop because we still need, we got about 15 more minutes of class. We need to put the numbers in. All right, so I'm gonna scroll up a little bit. But we got a few more steps. It's gonna be hard to let you guys
Miss
out
Doc,
early. You said
can
what?
you just paste? Can you paste the unknown part A and part B in the chat?
Chat? You gonna have to edit it though, but yeah. You're gonna check the
Oh,
video out later. It's gonna, the thing's gonna help you get it over to your notes, but not set up correctly, as you can see. So you gotta set that up. And I'll do the same for this part, but again, you gotta set it up correctly because it's not gonna have everything. I don't want you to lose points. So with that help, because we got a lot more to do.
yeah.
All right, there you go. There's the notes in the chat that I just typed up, but you have to edit them the same way I have to get full credit. In the chat, it looks like AX is all over the place, and so fix that up. All right, so let me continue on because I gave her what she needed. We need to now put our values in. So what does that look like? Well, with the summation sign, that means all the forces have the same amount of forces and they're being added together. So now we're going to plug our values in. So for summation of forces, here's what you get. You're going to actually put the numbers in. So that's going to be, what was ours? 80.7? Yeah, so 80.7. I'm doing part A, everybody. So 80.7 newtons, right? Plus, what's next? Well, it's 80.7 again, because all of them are pushing with the same amount of newtons. I'm going to put 1 newton in here. So it's 80.7 plus 80.7, right? And then all of these are newtons. So let me remove this. And these are newtons. And the mass is what? Well, there's only one mass we were given, and I got to go back up and see what that was. That was 765 kilograms. Now, we got pretty much everything we need, but we got to see what cancels out. Oh, messed up. Come here, you. Go back. There we go. What cancels out? Well, the kilogram, inside of a newton, you have what? You have mass times acceleration. So you basically, with a newton, you get this. You get mass, which is kilograms, times acceleration, which is measured in meters, or m, because we run out of space here, m/s, or meters per second squared. All right, all of that is being divided by 765 kilograms. Okay. Oops, that's not what I wanted you to do. This is what I wanted you to do. There we go. So you can see it better. So now we see this. Some things are going to actually cancel out. This is supposed to be raised to the power of 2, actually. There we go. Oh, look a lot better now. Okay. So what cancels? Well, kilograms goes away. So we can cross this part out. Because kilograms divided by kilograms. And so does these kilograms. All right. Let's clean the equation up so it gets smaller now. What does that become? Well, we end up removing this part, right? We end up removing the kilograms because they canceled each other. Now, we have a new equation. The meters per second right here, it actually just comes to the end of all this jazz. So remove that. And that's pretty much the end of it, right? We guys got to calculate it now. And I'll put this in the chat too in case you need it, but you got to clean it up. So what does this become, right? Well, let's put it down here and calculate it in probably Symbolab or Math Papa. I'm going to try Math Papa at first because you guys say Symbolab tries to charge you. But what does all this become, right? Let's calculate it. So I'm going to come to, what did I say, Math Papa? And I'm going to go to the algebra calculator. And I'll put this in the chats in case you need it for part B, because I'm not sure we have time. You guys got to try part B on your own if we don't have enough time. I'll try to set it up for you, but you got to finish it off. And then we didn't have enough time to talk about the asynchronous problem as well. All right, so Math Papa. And I'm going to type in what I see, right? So that's going to be, I need to say, hey, in parentheses, I'm going to say, what is 80 plus 80.7 plus 80.7 plus 80.7 close parentheses divided by 765 going to be? Right? That was what we had in our actual document. So I'm going to hit enter. And we get 0. Where does it say? 0.316. That's how fast it's going in terms of acceleration. So that's going to be 0.316 and meters per second squared. That's our acceleration. The first part. And I'm going to put this in the chat for you guys, because I'm going to talk about part B real quick. And part B is the same, but some things will change. So here is the notes on how we solved it. Okay. So I can't see Mr. Tyler. Pay attention. There are things that cross out, and you have to make sure you do the same. So I gave you that. And also your AXs and stuff, they have to match up. I mean, it's one thing to be like, oh, I'm not going to do it. It's another thing to be like, well, why didn't I get credit? Because you didn't do it. You have to make sure it's subscript and superscript and edit it the same way. Otherwise, I can't submit this to CPS and be like, oh, they did it right. They just did something. It has to be correct. All right, so part B. Okay, part B uses all the same steps, but we're going to, use some time travel or go at light speed to get it done, because we only got 8 more minutes of class, and I want to see if I can do this in 3 minutes to get you guys going. All right, part B is same thing, but now we have some changing in forces, right? Come up here, and in part B we got these values we're going to use. Okay, so pay attention to that. That means inside of, when you're doing summation of forces, some numbers will change in terms of what's negative and what's positive. So let me grab these steps. You need all these steps to explain what's happening with this next part on part B. So I'm gonna grab this and I'm gonna make some edits, and you guys do the same edits. I'll put it in the chat too when I'm done, but take a look. So I'm gonna put this, these are all the steps, but what changes, right? So we still have to solve for acceleration. I put that there again because that's what you got to do. But now the values change. So remember, it was who that went opposite. Well, it was Larry and Curly. Mo, he's still positive. So I think it's FM for Mo, right? That's the first value. The other two are negative. So that means that we have minus here, minus there, because that's Larry and Curly. And then you just go through and change the same things. So let me do that real quick. I'm looking at the clock. I'm doing this pretty fast. I'm pretty good. All right, so now all we gotta do is put the final calculation in. This is exactly how you fixed it for part B. As you can see, I edited so you can see all of the different phases where Larry and Curly are going opposite of Mo. All right, so this value is not going to be true, right? Because the number is going to change when we recalculate. Let's do that real quick. What do I have now? Well, if I go back to my original calculation, remember this is negative. Oh, it's 7. This is negative, right? Minus and minus. We're going to see a negative acceleration, right? Because there's too many people going against Mo. All right, so let's begin. When we calculate that, we end up with a negative 0.105. So negative 0.105. Okay. Second problem I want to talk about real quick. Let me put this in the chat so you can get these notes, but we're almost out of here and we don't really have time for share outs. But you need all this for part A. Part B, I'm sorry. So let me copy this and put this in the chat because we're about out of time. That's part B notes. I'm going to take that and put it to your document and edit it. It's 11:05. I'm going to be on here until 11:09 or 11:10, I guess. So I need to get the video ready. But I'm going to leave this on the screen. And if you have everything, don't forget you still have to take care of the homework problem. The homework problem is not as hard because you're just doing what force, right? On a 1,523 kilogram car can make it move at an acceleration of 3.78. What equation do you use for that? Well, I want you to set up your known and unknowns in that one. And you're going to use pretty much the same equation we've been using, except you only got one force that you're finding. You have the other values, whether you know it or not. And this is the easier problem, but this is a practice problem. So I should expect you guys to get this one done. All right, any questions from me though? No? You need me to scroll up? You guys hear me? They can hear me.
I was gonna say no. I don't need no questions.
Okay, so if you don't have everything, just check the video out, right? And it should show you how to get all this stuff done. It is due, both parts, asynchronous and synchronous work, by 8 p.m. tonight. Okay. I literally gave you the clues on how to tackle homework problem. All right, if you have no more questions, 11:07, you're free to go and get ready for GGI. Remember, the GGI link is same as Townhouse link. And I'll see you guys tomorrow. Don't forget to turn this stuff in PDF form by 8 tonight.
Mr. Tyler.
Who's that, Leah?
Yeah, can I see the part that you edited at, like, with the red?
For, you talking about part B or part A?
I think it's part A.
So if I come up here to part A, you talking about this part?
Uh-huh.
So part B is a little different. It's down here if you don't have it. But this is part A. Hello? Who is this? Somebody just came in the room. Wallace. Man, I just asked about you a minute ago, dude. You just came at the last minute.
Yeah, my bad about that. I had to take care of some stuff. Family minutes. Plus, I had court earlier.
Oh, okay.
Yeah, I had court.
All right, well, try to catch up, dude. Did you talk to staff about that, like Funes, or who did you talk to about that?
Who?
Did you tell any of the staff about what you had going on already or no?
I was trying to contact them.
All
I'm gonna
right.
tell them. Soon class over.
Yeah, class is over with, but I think you got another class with me, dude. Let me see what else you got going on.
Can you go down, Mr. Untitled?
Yeah, Leah, here. Telling to here?
Part B.
Yeah, so you got me for third period, Wallace. Just be on time at 12:20 for class, okay?
All right.
All right, go enjoy your day, dude. You got
That's
GGI, huh?
That's in what period is this right now? The
This is
second.
second period. Second period, sir.
Hey, Mr. Tyler, was it to do now right here? What's this you looking at?
It was, yeah. But the video is what I would check out. I'll try to send you the video when I process it in Esby, but it's always available in your library.
Yeah. Hey, you got that work I sent you to?
I think so. I think I sent you seen something you sent me. Let me check real quick.
I think
Aaliyah,
it was the do now exit.
you said the do now for what?
Yeah. Huh?
You said the do now for what, sir?
The robotics Friday.
Oh, robotics. Okay, let me see. So you didn't. Okay, so you didn't do anything for physics yet, but robotics. Let me see if I have anything from you. Wallace, did you email it to me?
Yeah, I think I did. It was quiz number 5.
Okay, I got to go in my list and see because you didn't put it in the grade book. You just emailed it. All right, so let me check and I'll get back to you. Okay, but get ready for next period. We got GGI. Do you know the GGI link or no?
No. You can.
I'm gonna put it in the chat. But if you see my screen, it's already in Esby. So let me grab it for you. And then Aaliyah, I'll go back if you need to do that. So the GGI and Townhouse link is always this. That's not what I wanted. I wanted this one. Come here. And you might want to save this link so you could always get to GGI. They go over what you might have missed in Townhouse, by the way. So it's opportunities and things you might need. So that's the link. Is the link in there? I don't see the link. That sucks. Hold on. There we go. That should go. There we are. All right, so that's a GGI link. You're going to use that to get to GGI. It starts in 3 minutes. So you might want to grab that and head over. And then I'll see you third period at 12:20, Mr. Wallace.
All right.
All right. Aaliyah, do you have everything you need?
Yeah, I'm done now.
All right, get the link and get to GGI, and I'll see you later on today.
All right.
All right.